Welcome to The Explainer. Today, we're diving into what I can only describe as an absolute engineering heist. It involves the very foundation of how our computers actually do math. We're going to look at two vastly different fields, artificial intelligence and decentralized finance, to see exactly how they handle a fundamental hardware flaw using two totally different breakthroughs that happen to share a similar name, a lens. Okay, let's just jump right in and shatter a massive misconception right off the bat. Do computers actually process exact math? I mean, intuitively, we all want to say yes, right? But the reality is, your computer isn't always doing exact math. Actually, when it comes to complex curves and continuous space, it's kind of just guessing.
I want you to meet what developers affectionately call the FPU gambler. Basically, your hardware's floating point unit. This little piece of silicon rapidly shreds mathematical exactness. Why? Because calculating complex continuous realities natively, it just takes way too much time. So the hardware makes a trade-off. It charitably sacrifices absolute deterministic perfection so that computers can process the continuous physical universe at literally the speed of thought. It just rounds off the decimals. It's incredibly efficient, sure, but it leaves an unrecoverable margin of error.
So here's our roadmap for today. 1. Anthropic's Jacobian lens. 2. Hitting the trig wall. 3. Smith's deterministic DeFi lens. And 4. The gambler versus the surveyor. Let's get into it.
Section 1. Anthropic's Jacobian lens. Observing the gambler.
Now, in the wild world of large language models, this FPU gambler is actually a feature, not a bug. AI entirely relies on those continuous lossy approximations to map incredibly complex, chaotic vector spaces. And that brings us to a massive discovery by Anthropic. Deep inside their Claude model, researchers found this hidden mental workbench they call J-space. Think of J-space as the model's silent intermediate reasoning zone. It's where abstract concepts are just kind of hovering, poised to become actual words before they ever appear in your output. It's like a cognitive waiting room where Claude might realize, hey, there's a bug in this code, or wait, this is a prompt injection, all before it spits out a single token.
So how do you even look inside this continuous, lossy thought space? Well, Anthropic built the Jacobian lens, or J-lens, which works in 3 specific steps. First, they probe the intermediate activation vector. That's basically the raw chaotic data firing inside the model. Next, they calculate the Jacobian matrix, which measures the exact causal effect that specific vector is going to have on future outputs. And finally, they map that vector using the model's own unembedding layer. So instead of staring at millions of totally unreadable activation dimensions, the J-lens translates the whole thing into a readable ticker tape of ranked vocabulary concepts.
What's brilliant here is that the J-lens completely embraces the FPU gambler's continuous vector approximations. Instead of fighting that lossy math, researchers use it. They use it to monitor the AI's reasoning, track hidden manipulative goals, and silently catch fabricated data. It basically lets us audit what the model is thinking, but not saying, entirely by reading those probabilistic hardware guesses.
Moving on to Section 2. Hitting the trig wall, the gambler's limit. But hey, what happens when you take that exact same continuous probabilistic math and try to force it into a super strict blockchain environment? Well, you hit the absolute core of our problem today. As the famous quote goes, the Ethereum virtual machine fundamentally cannot perform floating-point arithmetic or native trigonometric operations. Why? Because in a decentralized network, tens of thousands of independent computers have to reach the exact same mathematical answer to maintain consensus.
So, what actually happens when you hit this trig wall? It is a disaster. If you let the hardware guess the decimals, independent nodes will inevitably disagree, and network consensus breaks instantly across thousands of machines. Literally, billions of dollars could just vanish. Now, if you try to emulate that floating-point math and software on-chain instead, it causes severe punishing gas spikes. And worse, forcing the FPU gambler to guess how to fit a perfectly round curve into a discrete digital square creates these tiny, microscopic approximation errors. Under heavy market stress, those tiny errors violently compound, opening the door to catastrophic arbitrage exploits like dust grinding and sandwich attacks.
Which brings us to Section 3, Smith's deterministic DeFi lens, firing the gambler.
Okay, so if continuous math is basically toxic to the blockchain, how on earth do developers build multidimensional exchanges? The answer? They fire the gambler entirely. They did this through a massive geometric paradigm shift. See, legacy systems rely on Cartesian grids. Those are your rigid X and Y lines trying to map smooth curves using blocky squares.
It requires heavy floating point guesswork and creates absolutely insane gas overhead. But to scale up to n-dimensional liquidity pools without fragmenting capital, visionary developers completely abandon the grid for polar coordinates. This non-Euclidean circular manifold concentrates liquidity perfectly around a target price using mathematical rotation. It is an absolute game changer, especially for stablecoins.
But right here is the multi-billion-dollar question. How do you execute a circular rotation, which inherently demands trigonometry, right? Your sines and cosines, on an Ethereum virtual machine that literally cannot do trigonometry. To move along that circle without calling on the FPU gambler, developers actually resurrected ancient number theory. Meet Pell's equation. It's a Diophantine equation, which is basically a strict mathematical rule that demands pure, exact whole numbers. It completely eliminates decimals from the equation. Literally.
By combining Pell-Lucas integer sequences with these complex algebraic formulas called Chebyshev polynomials, the DeFi lens creates a flawless translation layer. It takes all that messy, infinite trigonometry and funnels it directly into division-free integer arithmetic. There's no division, there are no square roots, and most importantly, there's no guessing. They've essentially forced the math strictly into the realm of exact integers, creating an undeniable mathematical lock-in without a single decimal point in sight.
All right, Section 4. The Gambler versus the Surveyor. 2 paths forward.
Let's take a look at what happens when you rely entirely on the exact arithmetic logic unit, what these developers call the ALU surveyor. By firing the gambler, the DeFi lens achieves something honestly staggering. It drops metabolic energy consumption by 74 times, down to just 0.05 picojoules per operation. By speaking the hardware's native discrete geometric language, the code just executes with mind-bending efficiency.
And what does that mean for the user? It means constant time execution and a totally flat 0.01 gas efficiency. Because the exact integer identities mean the value itself contains its location. The machine isn't guessing where the liquidity is anymore. It permanently liquidates all observer debt. What you get is bit-perfect, universally verifiable truth.
So ultimately, we're looking at two totally divergent paths for the future of digital physics here. On the left, we have Anthropic's Jacobian lens, or J-lens. This approach totally embraces the probabilistic FPU gambler, mapping the chaotic, continuous vector spaces required to observe an AI's silent internal thoughts. But on the right, in total contrast, we have Smith's DeFi lens. This system outright rejects the gambler. It relies solely on the deterministic ALU surveyor to execute undeniable exact integer truth, to completely bypass the EVM trig wall. Which leaves us with this final, really provocative thought. Through these incredible breakthroughs in integer geometry, we can actually bypass hardware approximations and achieve absolute digital truth on-chain. So when we stop relying on the hardware's best guess, and we start building our financial primitives on unyielding, perfectly verifiable certainty, how will that change the future of trust? Definitely something to think about next time you dive into these systems. Thanks for joining me on this explainer today. Keep exploring, and I'll catch you next time.